Recording in progress.
Okay. Now I guess I can get the camera to focus. Okay, so rules for logarithms. Now there are easy explanations of these rules, and I'm probably going to talk about them a little bit. Make sure I can see all of this board. My H and M ran together there, but you know what I'm saying. Okay. The log of A times B is the log of A plus the log of B. And I'm not necessarily using the same letters your book uses. Different books use different letters, and I don't pay much attention to that. Okay, the two biggest ones are the log of A times B is the log of A plus the log of B, and the log of A to the n equals n times the log of A. These are related to rules for exponents in a way that I'll probably address, but let's just take the rules. Now, there's another rule for the log of A divided by B, but if you combine these laws, or these rules, you get that rule. So an unnecessary rule is that the log of A divided by B is the log of A minus the log of B. Okay. Now, if you divide A by B, it's like A times B to the negative 1, which would be the log of A plus the log of B raised to the negative 1. But B raised to the negative 1 would be negative 1 times log B, so you get this. So it's worth understanding that and thinking about it just to get a better handle on the rules. But those are the rules, okay? Now, a couple of false rules. I'll put a watch out here. Watch out. The log of A plus B, you're used to the distributive law. It looks like that ought to distribute to give you log of A plus a log of B. But it's not so. The log is not a linear operator. If it was a linear function, then, f of A plus B would equal f of A plus f of B, but only if f is linear, meaning it has a straight line graph. Log doesn't have a straight line graph. This won't happen. Okay? The graph isn't linear, so that's not so. And also, log of A to the n is not the log of A raised to the nth power. Again, it just doesn't work. Okay? So these are things you got to watch out for, because it's very easy to do this. And easy enough to do this. So those are pitfalls. Okay. Well, how does this apply? Well, let's just look at And we're going to log base 2 because we can easily understand the base 2 log. So log base 2 of x squared equals 3. Well, that means by this rule, 2 times the log of x equals 3. Log base 2. So log base 2 of x is 3/2. So in terms of what you've already done for homework, you understand that x is going to be 2 raised to the 3/2. Just changing this to exponential form. Okay? And that's about 2.828 because that's just 2 times the square root of 2. So that's straightforward. Okay? Let's take another example. Let's say we have I don't want to use a negative, we'll use a positive. Okay, base 2 logs. Now here we have a sum of 2 logs with the same base. And I haven't put bases on these. Let me go ahead and do that. This applies no matter what the base of the log is. So it could be base 2, it could be base 10, it could be a natural log, base e. So in this case, we have a base 2 log again. Base 2 logs on both sides are in this form. So now we know that this can be written as log base 2 of x squared multiplied by 2x plus 3 equals 2. So that x squared multiplied by 2x plus 3 equals 2 to the second power. That's a cubic equation. You have a 2 over here. Now that would lead you to the equation two x cubed plus 3x squared minus 4 equals 0. Now it's unlikely that that equation is going to factor. You can use the rational roots theorem, which I talked about a little bit, and you can test to see if 1 is a solution, but it isn't. 2 plus 3 is 5, minus 4 doesn't give you 0. Okay? You could see if 2 is a solution. Well, clearly not. Maybe negative 2 is a solution. That would give you negative 16 plus 12 minus 4. Well, if it was plus 4, it would actually be a solution, but it isn't. So you can investigate solutions. If you can find solutions, you can do a long division and use the process to solve the equation. Chances are it's not going to work because I didn't make up the numbers in order to make it work. Okay? Now the numbers are small and simple, so there's a chance it'll work, but probably not. So what you might do is sketch a graph or create a graph. You won't know exactly where the zeros are, but you can try some graphical solution to at least approximate the zeros. that doesn't change the fact that we've converted this equation to a simple polynomial equation. And we have methods for attempting the solution. And there are methods for approximating the solution. Okay. So with that, I'm just going to look at the homework for this section and just kind of go through that and give you some examples of the sorts of things you look at, but what I've already shown you is a good bit of it. And I'm going to kind of go, well, okay, you see how these rules can be useful for solving logarithmic equations. So now let's just look at how you would simplify one side of a logarithmic equation. Let's say you have the log to the base 3 of 4x squared, and the square should go over here so you can see it, minus log to the base 3 of 5x to the 9th minus 3. Okay? We can combine these expressions into a single log. Okay? This was equal then to log to the base 3 of 4x squared, and I can make that notation a little better. What happened to my other cloth? It's on the floor. Takes me a minute to get down there. Okay. So, log to the base 3 of this divided by this. Okay, and this uses the fact that log of A over B is log of A minus log B. So we have the log of this divided by this. Okay, let's look the other way. Let's expand the log of, could be any product. Okay, so let's say we expand the log of x to the 4th. Let's put a 3 out in front of here. X to the 4th, y to the 7th, z to the negative 5th. Okay, well, we're going to use the rule that says a log of AB equals log of A plus log of B. And also, we've got exponents of some of these things. Log of A to the n equals n log of A. Okay, so we get if I group these terms where the first two factors are grouped and the second two factors are grouped, turns out this is going to be the most efficient way to do this. We see that the log of this times this is the log of 3x to the fourth plus the log of y to the seventh z to the negative fifth. Just using this rule where a is your 3x to the fourth and b is your y to the seventh, z to the negative fifth. Now I could have grouped it otherwise. I might have grouped the x to the fourth, y to the seventh, z to the negative fifth, and the log of 3. So I'd have the log of 3 plus the log of x to the fourth, y to the seventh, z to the negative fifth. It's arbitrary how I do this, but the way I've done it is maybe the more efficient way to do it, because I need fewer steps. And you can think about how to minimize your number of steps. Basically, if you divide a long expression in half and then divide each of those expressions in half or close to being in half, it's a little quicker to get through the problem. Okay. Anyway, log of 3x to the fourth is clearly then log 3 plus the log of x to the fourth. And this is then going to be the log of y to the seventh plus the log of z to the negative fifth. Well, that's got it down into 4 separate terms, but now at least 3 of these terms have exponents, so we can apply the second rule, and we get log of 3 plus 4 times the log of x plus 7 times the log of y minus 5 times the log of z. So if, with a little practice, we learn to recognize these situations where these rules apply, it becomes fairly straightforward to break the thing down in a few steps and obtain the final result. Now, once you have a lot of experience with this, you can see, well, it's going to be, and you can actually do this, we're going to have the log of 3 and the log of x to the fourth and the log of y to the seventh and the log of z to the negative fifth. It's actually safe to skip this step and go directly to this step. I recommend that you do this step a few times until you're really convinced that you can just skip from this all the way down to this without having to do this. And then once you have this, you can write the rest of it out. And once you get used to it, you can actually pretty much just skip from here down to here. Because you're going to have the log of 3, and that's going to be it. You're going to have the log of x to the fourth, and that's going to be 4 times the log of x. And log of y to the seventh is going to give you 7 log y. And similarly with the z term. So you can kind of skip steps, but at first I recommend that you fill in all the steps just to make sure you see how everything breaks down. Okay. Well, I'm going to